Hello and welcome to O. Morgan Labs. Today we'll be talking about thermal expansion. Here's a typical problem you come up that you have when you're dealing with these problems. A metal cylinder's length increases 1% during a temperature change of 0 to 375 degrees C. A. Find the coefficient of thermal expansion. B. Find the percent change in density. First, we use the linear expansion equation. Delta L equals L alpha delta T. You realize percent increase is just dL over L. You rearrange your equation to be dL over L equals alpha delta T. Solve for alpha. You have alpha equals dL over L over T. Change 1% to decimal form, and you have alpha equals 2.67 times 10 to the minus 5 meter per meter K. Or, in most charts, the power is minus 6. So you change it to 26.7 times 10 to the minus 6 meter per meter K. Based on the value of alpha, you'd assume this was magnesium if you looked in a table, because magnesium is 25 to 26.9 times 10 to the minus 6 meter per meter K. Part B, percent change in density. To find the percent change in density, you need to find the volumetric change first. The volumetric thermal expansion is delta V equals V times 3 alpha. It's multiplied by 3 dt. Rearrange it, dV over V, that's our percent change in volume, equals 3 alpha delta T. You plug everything in, you get the percent change in volume is 0.03. We use your alpha delta T from part A. Okay, now we have that piece. Now let's go for the percent change in density, d rho over rho. We know that rho equals mass over volume. And we know that delta rho equals final rho minus initial rho, or final minus initial. Percent change in density then would be final density minus initial density all over initial density. You plug in your definition of density, mass over volume, you get mass over mass times the quantity, 1 over the final volume minus 1 over the initial volume, all over 1 over the initial volume. Now, it's just an algebra problem now. You cross out your masses, and then you bring your 1 over VI in the denominator. You can take the reciprocal, you bring the VI to the top. So you end up with initial volume over final volume minus 1. One more piece to this problem. You have to realize when you have percent change, you can multiply your initial times your percent change plus 1. So anyway, if you look at that like fourth line, final volume equals 1.03 times initial volume. Okay, percent change is 0.03. Now, your percent change density equation is initial volume over 1.03 initial volume quantity minus 1. You can cancel out your VI's and you get 1 over 1.03 minus 1. Plug that all in and you get minus 0.029. Change this decimal to a percent, move the decimal 2 places to the right, and you get minus 2.91%, which is a decrease since it's negative. All right, there you go. Parts A, part B, simple, well, not simple, but this is like, I think this is the most complicated you will get in these thermal expansion type problems. Okay, hope it helped you, hope you learned something, and don't forget to subscribe. O. Morgan Labs.